Okay, so question number 3. When sulfur dioxide and nitrogen dioxide are mixed, the following equilibrium is set up. So we have NO2 gas plus SO2 forms NO plus SO3. And the Kc value is 1.44. In one experiment, 1.64 moles of nitrogen dioxide was mixed with 1.64 moles of sulfur dioxide in a 4-liter flask. Step 1 is to construct an ice chart for this equilibrium. Step 2, using your ice chart, calculate the concentration in moles per liter of sulfur dioxide in the flask at equilibrium. Submit your answer to part B, given your answer to 3 significant figures. Do not include units since they are already stated in the question. Okay. So I'm just going to first calculate the concentration on top here for both my nitrogen dioxide and sulfur dioxide. They have the same number of moles and the same volume. So we can just do 1.64 moles divided by 4 liters is equal to 0.41 moles per liter. Okay, so this is the concentration for both nitrogen dioxide and sulfur dioxide. So now let's construct our ice table. We know that the initial concentration of both of these was 0.41, and the initial concentration of both of our products would just be 0, since we don't have any products at the start of our reaction. So the change that occurs is negative X for both of our reactants, and the change for our products is positive X. So now when we write out the concentrations at equilibrium, we get 0.41 minus X for both of our reactants, and we just get X for both of our products. Okay, so this is the ice table, or the ice chart. And now let's write out our expression for Kc. So Kc is equal to the concentration of our products multiplied together divided by the concentration of our reactants. Okay, so now that we have an expression for Kc, we can plug in all the values that are given. So we know Kc is equal to 1.44, and we know that the concentration of both of our products is equal to X. So X times X is just X squared. And the concentrations of our reactants are both 0.41 minus X. Okay, so now we just need to simplify this expression and solve for our unknown. So when we multiply the brackets like this, we multiply the first two, so 0.41 times 0.41, you get 0.1681, and then our inside term, so negative X times 0.41, and then the same outside term 0.41 times negative x, you get 0.82. So it's that first, outside, inside, last that they teach you in math. And then for last, you multiply negative x times negative x, and you get positive x squared. So now we have this quadratic formula as our denominator. Then we just need to expand this some more. So bringing our denominator, multiplying everything by 1.44, you get 0.242 minus 1.18x plus 1.44 x squared is equal to x2. And finally, we just need to bring our x squared over to the other side by subtracting it. And you get 0.44 x squared is equal to 0. So now if we solve for x using a quadratic equation calculator or a quadratic equation, you just end up getting 0.224 equal to x. And now we can calculate the concentration of sulfur dioxide at equilibrium. So we know it's going to be equal to 0.41 minus x, and we found x to be 0.224, and you end up with a final concentration of 0.186 moles per liter. Okay, so now let's see what the junior tutor said. Step 1 is to compute for the initial concentrations of nitrogen dioxide and sulfur dioxide. So they got 0.41 for both. And they constructed their ice table, yep. And then they wrote out the expression of Kc. And also got x is equal to 0.224. So now when finding the sulfur dioxide's equilibrium concentration, they also got 0.186. So this solution is correct.